Our neighbor Mars fascinates us. It's a planet that is similar to Earth, but with some big differences.
Mars is rusty, dusty, frigid, and frozen. It ain't the kind of place you want to raise your kids.
Past missions suggest that Mars was once a very different world.
The Mars we see today has completely changed from the Mars of a few billion years ago.
If I had a time machine to visit Mars in the past, I would go in an instant.
Without a time machine to explore ancient Mars, we employ a team of high-tech robot investigators.
We've got an entire fleet of robotic spacecraft exploring the planet.
Working together, they dig into Mars's past to answer the ultimate question: did Mars once have life? February 2021. The newest robot investigator speeds towards Mars, the most advanced rover NASA has ever sent to another world. This is Perseverance.
The goal of the Perseverance mission is to look for signs of past life on Mars.
First, it must navigate safely to the surface of the planet.
Every landing has its own dangers. Because the rover must be autonomous, it has to do everything without our help.
Perseverance enters Mars's thin atmosphere at close to 12,500 miles an hour. And deploys a parachute.
Navigation has confirmed that the parachute has deployed, and we are seeing significant deceleration in the velocity.
The parachute slows Perseverance to 200 miles an hour.
Current velocity is 83 meters per second at about 2.6 kilometers from the surface of Mars.
Still too fast to land safely. To prevent a violent impact, the rover must activate the sky crane.
When I first saw the sky crane concept, I thought, the engineers are kind of losing it. It seemed to me like a really crazy idea.
Perseverance activates its jetpack. Retro rockets slow the lander's descent to a crawl. Then, 66 feet above the surface, the sky crane uses cables to gently lower the rover to the ground.
Tango Delta.
Touchdown confirmed. Perseverance safely on the surface of Mars, ready to begin seeking the signs of past life.
Step 1 in the search for Martian life: find evidence of liquid water. A good place to start is the 28-mile-wide Jezero crater.
Perseverance has landed in a crater called Jezero, and this looks like a place where there was liquid water in its past. And the reason we think this is because there's this beautiful delta deposit right in the middle.
Perseverance turns its high-resolution cameras onto a cliffside in the crater and discovers giant 5-foot boulders near the top. A clue to how they got there may come from the first probes to visit Mars.
One of the very first things we noticed about Mars when we first sent probes there with Mariner and Viking was that there were these huge channels on the surface of Mars. Looking at these enormous landforms, we realized that in some places on Mars, there may have been enormous floods, bigger than almost anything we'd ever seen on Earth.
Flash floods on Earth cause similar rock formations to those found in Jezero crater, suggesting that powerful, fast-moving torrents carried the giant rocks found by Perseverance and dumped them at the top of the cliff. Perseverance is just one member of an elite team of robots patrolling the ground and spying from the air. The Mars Atmospheric and Volatile Evolution Orbiter, or MAVEN, investigates Mars's atmosphere.
MAVEN smells really good. It smells the Martian atmosphere. It tells us what the Martian atmosphere is made of all across the planet.
Then there's the Mars Reconnaissance Orbiter.
As its name suggests, an orbiting spacecraft that images the surface of Mars.
The MRO's high-resolution cameras can identify surface features as small as a kitchen table. And joining the orbital crew, the European Space Agency's Mars Express. With its ground-penetrating radar, it searches for evidence of subsurface water. And on the Martian surface, a group of high-tech landers take a closer look, including the team's quake specialist, InSight. This lander probes deep beneath the surface to discover how Mars's interior shapes the planet over time.
The InSight lander on Mars has a really simple concept. You land a spacecraft on the surface anywhere on Mars and then just listen for Mars quakes.
And 300 miles south of InSight, veteran rover Curiosity is exploring the Gale crater.
The mission goal for Curiosity is to look for habitability, and so that's environments in which life as we currently understand it could exist.
Curiosity searches for evidence of calmer, more permanent water in Mars's past. Investigating layers of rock at the base of Mount Sharp, a 3-mile-high mountain in the middle of the crater.
The rock layers start way up at the top of Mount Sharp, and they move progressively downward, and basically we're going backwards in time till we get to the very bottom. And the very bottom is actually really old.
Mount Sharp was built over millions of years, layer by layer. The rocks at the base of the mountain date to 3.5 billion years ago. These rocks are made up of very fine layers and could only have been formed in calm water.
These sedimentary layers were formed when Gale Crater was a lake, and sediment settles out and you get these beautiful layers.
Curiosity explores more of Gale Crater and discovers rounded pebbles like those we find on Earth.
When you see a rounded pebble on Earth, you know that that got rounded in a river channel. Some of them used to be angular, but their angles all got knocked off by being rolled and rounded and moved by water. So we're very excited when we see rounded pebbles on Mars.
The rock layers and rounded pebbles tell us that over 3 billion years ago, Gale Crater was a lake fed by rivers.
It was so exciting to understand liquid water in the context of Gale Crater, where Curiosity is. And that's just because what we see there is this long-lasting freshwater lake. And that's not like anything else we've seen on Mars before.
Imagine standing on the edge and looking out at this big, beautiful blue lake shining in the distance. What if there were just a whole array of craters filled with water off in the distance? It would be so beautiful.
And a good place for life to evolve.
Mars was a nice place. It was probably more like Earth is now, so it wouldn't surprise me if it supported life. We're talking microbial life. We're not talking, Marvin the Martian or anything like that, but life still is life.
Any water Mars once had is now long gone. To stay liquid, water needs warmth and atmospheric pressure. While robot team members Curiosity and Perseverance work the Martian surface, 8 probes orbit the planet, searching for clues about Mars's ancient wet history. Leading the pack is MAVEN. Its mission? To solve the mystery of Mars's lost atmosphere.
Today, the atmosphere of Mars is incredibly thin. It's only about 1% the atmospheric pressure here on Earth.
The weight of gas in an atmosphere pressing down creates pressure. And that pressure dictates at what temperature liquids boil.